This video is a quick review of the algebra concept of writing the equation of a line in a form that you may or may not be very familiar with from Algebra 1. We're going to start by relating the idea of a line to the fact that all points that are on the same line have the same slope between them. So if we start out here at number 1, if we calculate the slope between the point A, which is 1, 3, and the point B, which is negative 1, 2. We'll use the slope formula, and we'll say, okay, well, the slope is 3 minus 2 over 1 minus negative 1, which is 1 over 2, 1/2, right? And then if we go and calculate for part number 2, the slope between the point, let's see, 7, 6, and 3, 4. That slope, if we calculate, the slope is going to be 6 minus 4 over 7 minus 3, and this is Algebra 1 stuff. We got 6 minus 4 is 2, 7 minus 3 is 4, which of course reduces to 1/2. Alright? If we look, we've got these 4 points, and they're all, the word we'll use in math is collinear, because they all lie on the same line. The slope is up 1, to the right 2, rise is 1, or run is positive 2, and we all have those points in the same line. So we want to introduce what I'm going to call a variable point. Just a general point somewhere floating out here on the coordinate plane. Hopefully it'll be on the same line, but we're just going to call it the point xy. And I'm going to start out very simply by saying, well, how would we find the slope between the point x and this point c that we had 3, 4? We're going to use the same idea of calculating rise over run. We're going to say, well, that's y minus 4 over x minus 3. And that's the slope. We can't reduce it simply like we could with the other numbers, but that's the general idea. We're going to move to extending that idea of writing the equation of a line based off of the slope. So now we want to write the equation of a line to represent all of the points x, y that are on the line through the point negative 1, 2. We're going to take the same idea. We're going to say, okay, well, here's negative 1, 2. Let's introduce a variable point, xy. And we're going to first start out by finding the slope. We're going to say, okay, well, y minus 2 over x minus negative 1. And we want that to be equal to 1/2. We want the slope between our point xy, our general point that's somewhere out there on the coordinate plane, and the point negative 1, 2, we want them to have a slope that reduces to 1/2. And this equation should theoretically get us points that meet that description. We're going to simplify it a little bit. I'm going to say that this is the same as saying y minus 2 over x plus 1 equals 1/2. And the only thing that I don't like about this is that you'll notice that there's one value that I can't plug in to this, which is the point negative 1, because it will be dividing by 0. But clearly negative 1 is on the line. And that kind of presents us with an inherent paradox, because a graph is supposed to represent all the points that make an equation true. Negative 1, 2 would be on the graph of this line, but negative 1 could not be plugged into the equation. So to fix that, what we're going to do is we're going to multiply both sides of this equation by the same value. Multiplying both sides of the equation by the same value doesn't change the equation at all. And we're going to be careful about what value I choose. I'm going to multiply both sides of the equation by the expression x plus 1. And you'll notice what happens is this x plus 1 divides this x plus 1 and makes a nice 1. So the left-hand side of the equation is y minus 2. And here we get x plus 1. This equation right here represents the equation of the line with slope 1/2 through the point negative 1, 2. If we take all of the other equations, or excuse me, all of the other points that are on this line, for example, 1, 3. And so we see we've got the point 1, 3, and we want to write the equation of the line through that point such that the slope is 1/2. We'll do the same technique. We'll introduce a variable point. And we'll say, okay, well, y minus 3 over x minus 1 equals 1/2. And then because I don't like this x minus 1 in the denominator, we'll multiply both sides by x minus 1. Y minus 3 equals 1/2 x minus 1. You probably are noticing that whatever this denominator is always just appears right here. So we're going to kind of extend and say, okay, let's find the equation of the line through the points, let's say 6, -7, and 7, -5. You'll notice what's missing here is that we don't have the slope, but we can fix that because we can easily find the slope. So the first thing we're going to do is find our slope. The slope that we're going to look for is between 6, -7 and 7, -5. So we'll say, okay, we'll do a little calculation. Let's do -5 minus -7 over 7 minus 6, which we get 2 over 1, which is just 2. Okay, so the slope we're dealing with is 2. And we need one other point on the line. It doesn't matter which point we use. I'll use 6, -7. I'm randomly choosing this point. I could have equally chosen this point, and I'll actually do that next. So we'll start out by introducing our variable points, and we're going to say, okay, well, this is y plus 7 equals our slope times x minus 6. I could have chosen out the other point. I could have started with 7, -5, in which case I'd have y plus 5 equals 2 times x minus 7. And you might be looking at it and say, this looks totally different than this, except for the fact that they have the same slope. Now I'm going to just prove that these are in fact equations that represent the same line by, I'm going to solve for y. I'm going to distribute. Let's say y plus 7 equals 2x minus 12. Then when I subtract 7 from both sides, I get, and isolate the y, we get y equals 2x minus 19. I'm going to go over here and do the same thing. I'm going to distribute the 2 through. We get y plus 5 equals 2x minus 14. So y equals 2x minus 19. And you'll notice that this equation and this equation are equivalent to each other. That's because they represent the equation of the line that passes through these 2 points. And it doesn't matter which point we use to write our equation because they're on the same line. So just to, in order to be able to write the equation of a line, the first thing you need is a slope of the line. And the second thing you need is any point on the line. It doesn't matter which point you use on the line, any point will make the equation represent the graphed points that are on that line.